Hey there, PreCalculus fans. Going to finish this little series on inverse trig with an applied problem that's similar to, I think it's directly from one of my old final exams, that puts everything together. So this is a big problem, but I hope I can help you identify where the pieces of understanding are. Now, this particular problem is a weight attached to a spring from the ceiling. I've made this animation to go with it. It's set up, the spring pulls it. This is a very important problem if you take differential equations or if you go on into physics, because it's a critical example of oscillations. And in the last month of Math 207, you're really solving a lot of equations like this. What if there's friction? What if there's not? So it's a big topic. The animation I made is starting there at the low point. So they tell me the low point. I've slowed down time so we can see it better. Then it comes up to a high point. It told me that time too. I've rounded the numbers there. And it goes back down. It does this for 20 seconds. The question then asks about when is it above 28? So that's its own challenge. Only here is it above 28. So we want to find the times when it's above. So we really need to find those intersections. So a question like this is asking multiple things. Find the model, find the intersection, interpret correctly. So it's a lot to put together sometimes for a student, but it also means there's plenty of things for you to do. So let's go back, let's find the model. And hopefully at this point you're getting better and better with what the model is. Like hopefully you can look at that and see the critical values that we've been talking about. They're there. You might say, don't we have these formulas? Can I use the formulas? Yes, you can. So rather than go through that again, because I think that's a little bit more straightforward and something you can check, I've just done it. So I computed A, I computed D, I computed the peak to peak, I computed the C value, I graphed a picture. That is some work. That's something you would need to do. Then you would say, all right, I want to know when it's 28. And you're trying to find all the solutions up to 20. And we know how we do that too. First we find one solution and then we use the graph to find the rest. So I'm going to show you that as well. I just want to paraphrase ideas here. I started to make a full video and I realized it was going to take too long. Everyone would be asleep. You say, we're already asleep. What are you talking about? So there's my solving. So I set it equal to 28. I know the question says when it's bigger than 28, but a question like that, always find what it equals 28. I subtracted 26, I divided by 11, I hit the inverse sign button. Here is the moment where if you're trying to use the algebraic technique, you'd have to appropriately deal with pi, but I mentioned how I like to work directly from the graph. And then we're almost done. So we need that value. And I got that it was about, I'm just going to paraphrase, 7.46. The rest of the question becomes reasoning from that value. So for example, you can add 8.8 to get this one. You can add 8.8, and this is like 16.26. You can add 8.8 to get the next one, but that's actually past 20. So you're like, okay, I don't need this. Then the job becomes finding the symmetric solution. So this is where you use that helpful idea of b over 4, which I think is 2.2. And this little spot here is 7.2. And so we know that because that's the C. So if we go a fourth of the period, we're going to be at 8.4. How about 9.4? Sorry to laugh at myself. Okay, so to finish the problem, we need to do 9.4 minus, 9.4 minus 7.2. Not 7.2. I've lost my, laughing at myself made me lose this, is 4.6. I need this gap. I need to add it on, and then I have it. So let's bring our Oops, I lost my calculator, friend. That's the graph. Well, let's do it without my calculator. Okay, so we're doing 9.4. I have my calculator. I'm not ready to display it. 0.46. Okay, so we're getting 1.94. We're going to add that on to 9.4. Just checking my numbers here. 11.34. And once we know that, we know the rest. We can add 8.8 again. Let me do that quickly. I got that it was a little more than 20. So if I do this plus 8.8, yeah, I got 20.4. 1.4. So I'm only going to go to 20 and stop. So I need this length of time. So 20 minus 16.26. I need this length of time, which is actually just 2.2 times 2, so it's 4.4. And I need this little length of time. That's kind of sneaky. So I need to go back 8.8. So 11.34 minus 8.8. I got 2.54. So altogether, that I'm getting it's above 28 for the first 2.54 seconds. And then for 4.4 seconds, not 4.4, why am I trying to say that? 2 times 1.94 seconds. That's this time. And then lastly, 20 minus 16.26 seconds. For a grand total of like 2.1, I think is what I got before I did the video. Now I didn't write that down. 9.4 plus 20 minus 16.26. Yeah, so I got about 10.1, 10.2 seconds. 10.16, but I'm rounded a whole bunch there. That was the idea. So it's multiple steps. I understand if you're worried about this question, but I think there's plenty of things for you to do. Finding the model, solving for the principal solution. I think we all should be able to do that fairly quickly. Finding the symmetric solution, that's going to require you have the graph and do some reasoning. And the last part is making correct conclusions. So I want you to help identify where, the goal of me doing this is try to help you see where your confusion is. But I hope that helps, and I hope the visual is something of interest to you. Pull the visual in. Hope that making these is helping someone for that game. So about 10 seconds in that time, those 20 seconds, so about half the time it's above. And the reason it's half, you might say it shouldn't be half. I started to doubt myself for a second as I was looking at that. You might say it shouldn't be half the time because it's not. Oops, I may have changed the wrong number. But we're not going a full period. It's definitely like here it's not half the time, but because we're above here, that's what changed it. A separate question would be what percentage of the time in one cycle is it above or below? But that wasn't what the question asked. All right, hope that helps. Let me know if it does.